On to the last video in this playlist, atomic structure, onto nuclear fusion. Nuclear fusion. Reminder, nuclear fission is the splitting, nuclear fusion is very much the joining, and it's the joining of two small or light nuclei in order to form something heavier. There are many different types of example that I could have chosen, but I've chosen in this case hydrogen, so one proton, to join with another hydrogen, but a different isotope because it's got a neutron and one proton. That then joins with a mass number of 3, 2 protons, and then 1 neutron. So then we get helium because it's got 2 protons. And then each one has a name, so this is hydrogen 1. Hydrogen 2 has its own name, deuterium. If it was H3, it would be tritium. And they then join to make helium 3. If you look on the periodic table, it's helium 4 because in the periodic table there's an extra neutron. But in this example, the one that I've chosen is helium 3. You may have heard of Einstein and his famous equation, E equals mc squared. That's where energy can be converted into mass, and conversely mass converted into energy. In this process, some of the mass gets converted into energy. So next to here we could have plus energy, and we see it in terms of radiation. Scientists want to explore more about nuclear fusion because it will generate far more electricity than nuclear fission does. This is what happens on the sun, and it's how our sun generates the light and heat that we feel. But as yet, on Earth, we haven't really been able to get it to work for what we need. We can get a little bit of energy from it, but not the quantities that we're going to need in order to use this in our daily lives. If we think about what's going on here, we've got hydrogen, which is actually a proton, trying to join with another proton, both of the same charge, trying to get them close enough to each other to fuse into one helium requires an awful lot of energy. On the sun, it's got a huge amount of gravity that encourages them to get closer, but we don't have that on Earth, so we have to use energy. So we have to heat it up really, really hot in the hope that then even more energy gets released when it converts into helium. So something to research if you're interested in this is cold fusion, because for this to work on Earth, we need to work out a way of getting this to fuse, but at much lower temperatures than are what's currently possible.